these lectures, that is on the complex topics related to different subjects. I'm going to continue my third lecture, which is related with Unit 3. That is basically the particular techniques which is used to solve the optimization problems. And specifically, I'm taking the greedy methods. So in this particular lecture, I am covering this greedy methods, what is the use of these greedy methods, and some of the particular algorithms which follow this approach related to this greedy methods. So my covering content is a greedy method, activity selection problem, task scheduling problem, and fractional knapsack problem. So what are the basics of greedy methods, and these are the kind of problems which we are going to solve using these greedy methods. ग्रीडी मेथड, मैम पीपीटी नहीं ठीक है ना, उसमें इधर चली जा रही है, यहाँ देखिए उस स्क्रीन पे नहीं ठीक आ रही है, यहाँ ठीक है ना? हाँ ओके पक्का? हाँ। तो दोबारा तो नहीं शुरू करना पड़ेगा, अभी यहीं से स्टार्ट हो जाएगा? ठीक है ठीक है. So if you are talking about greedy methods, so algorithms for optimization problems. So firstly we try to understand what is optimization problems. Means this problem. What is basically these optimization problem? So optimization problems are those problems in which we have number of solutions. Out of that, the particular solution which generates the values either maximum or minimum, that is basically called optimization problems. Means there is no single solution exists for that, multiple solutions are there and we have to choose the best out of that. So for these particular problem, these are very complex problem, and these optimization problems typically go through a sequence of steps and ultimately a set of choices at each step. So important thing is that whenever you are reaching a step, you are getting number of choices. Out of that, you have to select the best. And for that best, some of the approaches are used to find that best. So greedy algorithm is one of the out of that. So what is greedy algorithm? A greedy algorithm always make the choice that looks best at that moment. So that particular choice is called greedy choice. So the name is greedy because at that moment you have to select the best choice. So that is the process for greedy method. That is, it makes a locally optimal choice. The important thing, the greedy method, you cannot get by using greedy method, you cannot get the optimal solution, means the final solution. What it is doing? This particular approach is only finding the locally optimal solution, means at every step you are getting the best solution at that moment, and at last you have to just integrate the solution for finding the optimal solution. So it makes a locally optimal choice in the hope that this choice will lead to a globally optimal solution. And most of the time, whatever algorithm that would be approached by this greedy choices, they will provide the best results using this phenomena. So it is basically called top-down approach. Okay, it is basically top-down approach because whatever final solution you will not get, exactly you are getting the separate solutions. So the greedy method is quite powerful and works well for a wide range of problems because it is using for optimization problems. What are the elements of greedy strategy? The important thing when we are going to solve the greedy problems, then definitely some of the steps are involved through which we can just apply that algorithm for any given problem. So the first step is determine the optimal substructure of the problem. What do you mean by optimal substructure? Basically, optimal substructure is a basic fundamental thing that would be associated with the given problem. Means the solution is in the form of maximum or minimum. Like if you are talking about minimum spanning tree, it would provide the minimum solution. So our optimal substructure would be different because when we are getting a tree, the first structure is that we cannot take any graph, we cannot have any cycle or whatever result we are going to find, like minimum spanning tree, because value is the minimum. So definitely we have to select the firstly minimum things and we have to find out the optimal substructure. So optimal substructure optimal substructure of the problem is basically defined in terms of what kind of optimization problem is there. Second, develop a recursive solution. How we can solve every step. Means in first step we are getting some solution. We have one particular formula. Then definitely this formula is again used for second step. So there you have to develop a recursive formula. And third, prove that at any stage of recursion, one of the optimal choice is the greedy choice. It also proves that every moment you are getting the best solution at that moment, and that solution is only one, not more than that. That is very important, whatever process you are using. So you have to apply the step 1 and 2 in the hope that you are getting the best solution for every particular choice by using this greedy algorithm. And fourth thing, so that all but one of the subproblem induced by having made the greedy choices are empty. So only one particular greedy choice is available, that is the final solution. Another, if greedy choices you are taking, that is basically empty, means one choice is only there. Then develop a recursive algorithm that implements the greedy strategy, whatever defined in these 4 steps, that would be developed by an algorithm, and convert the recursive algorithm to an iterative algorithm. Then we have to find out, we have to perform the different steps for that. Definitely we have to reiterate the whole process. So this is the element of greedy strategy, and it is very important aspects. Now, what are elements of greedy strategy? When you are going to apply any greedy strategy, then what are the elements? The first important element is cause the optimization problem as one in which we make a choice and are left with one subproblem to solve. So firstly, you have to cause that optimization problem in this term, that whenever you are going to solve a particular step, rest of the steps will be available. Means this is a kind of sub-problem, not the whole problem. So you have to solve that sub-problem, then again switch to another sub-problem, then again solve. Then you have to find different solutions and finally integrate it. The second, prove that there is always an optimal solution to the original problem that makes the greedy choice, so that the greedy choice is always safe. So that is very important. When we are getting that greedy choice, we have to take the safe greedy choice, so that we don't have any contradiction to the process of that particular algorithm. Like when you are talking about a minimum spanning tree, definitely we have to take one edge and add it into the tree. But one important thing is there, that edge should be safe, means it would not make the cycle. So that is the constraint at that time. We have to cater this constraint for that particular thing. And third one is demonstrate that having made the greedy choice, what remains is a subproblem with the property that if you combine an optimal solution to the subproblem with the greedy choice we have made, we arrive at an optimal solution to the original problem. Whatever solutions we are getting through applying this greedy choice, these particular solutions combinedly make a solution that is treated as an optimal solution. That must be ensured by using these algorithms. Then one important thing, what is greedy choice property? So first key ingredient is the greedy choice property. That is first element. A globally optimal solution can be arrived at by making a locally optimal, means every moment we have to take the best solution. Then optimal substructure, a problem exhibit. Optimal substructure we have already discussed, but again I am repeating that a problem exhibit. Optimal substructure, if an optimal solution to the problem contains within it optimal solution to the subproblem. This property is a key ingredient of assessing the applicability of dynamic programming as well as greedy algorithm. Whenever we are talking about greedy algorithm, the dynamic programming is also concerned, because it is also a kind of algorithm which solves the optimization problems. Now we have to switch over to activity selection problem, the first problem related to greedy algorithm. What is basically activity selection problem? We have n number of activities. These are proposed activities, and these activities will use some resource like a lecture hall. If you are going to taking a class in any lecture theater, definitely when one class is progressing in that lecture hall, we cannot assign second class to that lecture hall. That is the constraint. So limited number of resources are there, number of proposed activities are there, and we have to use that resource one at a time. So what we need to basically, the objective of this problem is to find a solution, find a schedule through which we can maximum utilize that particular lecture hall. So for that, what is needed? How we can generate the optimal substructure of the problem? So you know that every activity is time bound. Some start time is there, some end time is there, and definitely when the activity will start, during that time till the activities end, we are not able to conduct any activity in that particular lecture hall. So these are the some components are required in which basically start time is there. Every activity has some start time, some finish time, and the ratio between start time and finish time is basically this. The start time is lesser, 0 is lesser equals to, might be first activity will be start, the time would be 0. So SI is lesser equals to basically greater or equals to 0. Then Fi, whatever Fj is there, that would be greater than Si every time, and Fi would be less than infinite because it is not unrealistic value. So this is start time and end time is associated with every activity. Now we have to find out the compatible activities. What are the compatible activities? So activities Ai and Aj are compatible if the intervals Si, Fi and Sj, Fj do not overlap. Then it is only compatible. Means Ai and Aj are compatible if the start time of I is greater or equals to finish time of J, or start time of J is greater or equals to a finish time of I. So that would be required, because when we are going to perform that activity, you would ensure that there is no activity conducted at that time in that lecture hall. So it is very important. So the activity selection problem, what is the objective of this problem is, the activity selection problem is to select a maximum size subset of mutually compatible activities. Means we have to maximum utilizing that particular lecture hall, and maximum number of activities for a given time slot will be conducted into that particular resource. So that is the objective. Now, what is the constraint? Let us assume that the activities are sorted in monotonically increasing order of finish time. So finish time is sorted so that whatever larger finish time is there and what is lesser time is finish time is there, we have to accommodate both. So first optimal substructure is what? You have to take the finish time input as monotonically increasing order. Now, this is the recursive activity selector. Okay, this is the algorithm, Gredy algorithm, which is used to calculate the number of particular activities which is compatible for a lecture resources and maximum compatible activities. So this is the recursive activity selector. There are two algorithms which is used for that. One is recursive activity selector and next one is Gredy activity selector. So recursive activity selector, you have to see the argument: start time, finish time, first item and last item. There is a m variable, m equals to I plus 1, means the initial activity, because I equals to initial time. So m equals to I plus 1, while m is less than j, means that this shows the activity. M is less than j and the start time is less than finish time. Find the first activity in Sij. So that should be required. Whatever activity you have chosen, we have to take in it as a serial order. First activity we have to take. So that activity, first important thing, that should not be last activity or greater than last activity. So we have to check that this activity is less than the number of total activities. The first important thing. Second, how we can select that as an activity? When SM, the activity of start time of this activity, is less than finish time of that activity, means same activity. Okay, so first activity is selected. Do m equals to m plus 1. If this activity is compatible, initially the first activity is compatible, we can take that. So m equals to m plus 1. Now the activities, one activity has been selected. Now if m less than j, we have to follow this for next activities. Then return. If m is less than j, for second activity, m plus 1 is there. So second activity is there. We have to second activities. Activity list is less than the total activities. Definitely if it is less than total activity, then return am. Am means the particular item union recursive activity selector. Now this I initial item is converted into that particular item which is actually your base item, initial item, because M is now initial item. Now we have to take the start time of M and end time of M. Both time you have to calculate it. Then whatever new activities will appear, you have to check this constraint. The start time of this activity will be less than finish time of that activity. Definitely where this particular synchronization is there, at that time this process will be gone. So now this is the example for that. We have total 11 activities given. The start time is 1, 3, 0, 5, 3, 5, 6 something. And the so this time you have to see, this time is increasing order monotonically. Now we will see that how we can select this. So you will see here, A naught is selected, A naught is initial time, that is 0 item. So first item will be selected 1, 1 and 4. Okay, 1 is the time. So recursively elective M equals to 1, A1 is selected. Okay, A0 to A1. Now if you are selecting A1, the finish time of A1 equals to 4. You will check that. Now you have only select that particular item which have either greater than or equals to 4 time initial time, because till the 4 the particular event is executed in that lecture hall. After that, so the initial time is 4 or greater. You will select that as an item. So you will check the second item having 3 initial time, start time. So it is not possible during 4. Next one is 0. You have to skip it. The fourth one is 5. The fourth item set is 5. So definitely 5 will be conducted into that lecture hall. So now A4 is selected. The next item is A4. Now the initial start time and finish time will be updated. So 5 is start time and finish time is 7. Definitely the next activity must have the time, start time greater or equals to 7. So we will check for next. So A1 is selected, A4 is selected. Now A8 is selected because this finish time is greater than 7. Now again, start time is greater than 7. Now again, we have to check the finish time of this particular A8. So it is 11. So now whatever activity is having time, start time more than 11, we would choose that. So this particular activity is discarded, this activity is discarded, this will be only taking. So now the activity sets are A1, A4, A8 and A11. These 4 activity set has been executed in that particular lecture hall by using this formula. So you will get that every moment you are getting the best choice. Initially A1 is the best choice at that moment. Next step, out of 2, 3, 4, 4 is the best choice. Next step, out of 5, 6, 7, 8 is the best choice. And for the next step, out of 9, 10, 11, the 11 is the best choice. So that is assuming that the activities are already been sorted, finish time, the running time of the call. So whatever complexity is, recursive activity selector is basically theta of n because one time is executed. So it is activity selection problem. Now greedy activity selector, it is very easy. Either only start time and finish time. N equals to length of S. Okay. N means length of S means how many number of items are there. We have to take A1 initial item, I equals to N. Now we have to process this for second to last item. Definitely you have to check the start time of this particular whatever you have selected, that is M equals to initially I equals to 1 and M equals to 2. So for second item you have to check, and that is the criteria. The start time for second item would be greater or equals to finish time of first item, that is I equals to 1. If that particular criteria is fulfilled, what you have to do? You have to just take that item as per the collection of that. So A1 and AM. Then I equals to again M, return A. Then again I equals to M. Up next item that would be updated. Like if you are taking first item and fourth item is there, then fourth item is updated. Then the start time, finish time of fourth item will be considered. Then again we have to, for third item, whatever item is there, we have to check it. So we have checked for every item, but we have to add only those items that would be falling in that category. So that is iterative greedy activity selector, and it is very easy than the previous algorithm. Now second problem is task scheduling problem. What is task scheduling problem? We have unit time task and we have unit time to exactly complete that task. Means we have available unit time for that, and there are penalty for that if you are not executing that task in within the time, and there should be some particular time frame is given for executing that task. So that is called task scheduling problem. Then what we are doing, the problem of scheduling unit time task with deadlines and penalties for a single processor has the following inputs. So these are the inputs. S is number of items, unit time task, number of deadlines associated with that. Then number of deadlines means in how many time we will execute these particular tasks. Then penalties are also associated. If you are skipping any task, definitely some penalties imposed. So what we are doing, we are asked to find a schedule for S, means this particular task scheduling problem, that minimizes the total penalty incurred for the missed deadline. So we have to make such a schedule in which we missed only that particular task which have the minimum penalty. So again, this is greedy problem, because every moment we have to find out the particular task which have the maximum penalty must be executed. So whatever process you are going to apply at that moment, you have to check for that greedy choice. So now we have to consider this problem, that is A1. A is number of tasks, deadlines. For one task 4 deadline is there, for 2 tasks 2 deadline is there, 3 tasks 4 deadline, the deadlines are given. And the important thing, we have to take penalties as per decreasing order, so that we have to cater the maximum penalty oriented task initially. So now it is given. So you will see that the total number of time is given for a task is 6. So we have to write down these 6 lines. So these are 6 lines, and we have to accommodate the task for particular time unit. For example, task 1 is, at most you can execute this task before time frame is 4, means before this you can execute this particular task in unit time, means it can be executed by unit time 1, by unit time 2, by unit time 3, by unit time 4. Suppose we are executing this particular unit time as 70 is for 2, for 3, suppose. So task 1 is executed as 3 unit time. The second is 2 unit time, basically, okay. Then we have to take it as second. The second executed in this. The third is executed at 4 unit time. Now we have to take in 4. Fourth unit time is basically third item. So third item is executed in 4 time frame, although taking 1 time. Now fourth is executed at third. You can see that 3 unit time. So we have to empty this particular part. So 1 is placed here and 3 is placed there. Fourth is placed here. Now you can see that all the particular task is executed within their time frame. The one task is executed at 4 unit before 4 unit task. 2 task is executed before 2 unit task. Third task is executed before 4 unit task, and 4 task is executed at 3 unit task. Now we will see next 5. We can skip that because 1 unit time frame is not available at that moment. Now you can see that this 6 is also skipped. So 1 and 6, these are not executed. So total missed deadline penalty is 30 plus 20. Now it is incorrect because we have already used this particular time frame. Now 7 task is executed and 6 time, and we are having this 5th and 6th time. So it is not problematic. You can take any of the time frame for executing this 7 task, and the total penalty is incurred through this schedule is 50, and that is minimum. So that is greedy choice. If you are randomly you are using this, maybe you can use any of particular. If you are not just constrained that the minimum penalty would be incurred, then you can take, means you will find any number of particular task executed within any time, and you will get number of penalties incurred, because at a time 2 particular items is removed or any item is removed. So you will get different penalties criteria, but out of that we have to choose the minimum penalty. So that is again a problem of greedy algorithm. Now the fractional knapsack problem, it is very important problem and it will take time to understand. मैम कितना टाइम बचा है? नहीं, मैं इसलिए पूछ रहा हूँ क्योंकि इसको करने में मुझे 5 से 7 मिनट लगेंगे. कर लो ना. हाँ, मैं इसीलिए बोल रहा हूँ क्योंकि वो पता चला टाइम हो गया फिर गड़बड़ हो जाती है. थैंक यू. Now we come to fractional knapsack problem, and it is very important problem because greedy and dynamic both apply this problem. And when we are going to differentiate greedy and dynamic problem, this particular problem is very important to differentiate both. The fractional knapsack problem is used for greedy algorithm, and 0-1 knapsack problem is used for dynamic programming. Why greedy algorithm? This fractional knapsack problem, because there is a knapsack, means there is a bag, a thief come with the bag in a store and want to steal the items and want to keep those items which he want to steal to keep into his bag. That is the basic problem. The important thing, he want to take that item for a store which have the maximum benefit, so that whatever bag size is there, he will get the maximum benefit out of stealing that items. That is the phenomena basic, the knapsack problem. So things of items, this a thief can take fraction of item. The first problem, think of item in G1 problem is like that, but we are here discussing the particular fraction problem. Now the problem will be solved by using greedy algorithm. What we are doing? We have a knapsack, there is some capacity of knapsack, we have items, there is weights of item, we have profits associated with that item. Now we have to select the items with greatest profit to fill the knapsack. That is the problem of fractional knapsack problem, and only one particular flexibility is there, you can take fraction of item also. So what is fractional knapsack problem? You will see the algorithm. Firstly, you have to find the important thing. What are the argument for that? One is basically W. W means weight, the complete weight of item or individual weight of item. Then only 3 variable is required. Initially what we are doing, firstly whatever profit size is there, firstly we find out the cost of individual item. 1 unit item of every item, because the particular value is given in terms of the complete set of item. Because maximum profit item, how you can calculate? Firstly, find out per unit item profit. Per unit item profit is greater for that particular item which having the maximum profit. So firstly, whatever profit of that item and whatever total weight of that item, we can find this per unit cost. Then sort descending, because sort descending means we have to store the particular cost is descending order, so that when we are picking the topmost item, definitely it will have the maximum profit. Now I equals to 1, while I is less or equals to size of V. Whatever size is given, I is less or equals to. If Wi is less or equals to W, suppose whatever item you are going to take that is less than knapsack capacity, then it would be included. Then the updated W is W minus Wi, and the profit is added into the particular value. Again, total equals to total plus Vi, whatever profit is already there and whatever profit you are gaining to keeping that item into the bag. You are getting this. At last, if Wi is greater than W, suppose some item which is greater than W, okay, then what we have to do? I equals to I plus 1 and taking their fraction, okay, and taking their fraction. So whatever space is available for that knapsack, we have to fill the whole space till the number of items, mean the weight of item is greater than the knapsack capacity. If it is equals to knapsack or less than knapsack, then obviously the knapsack is not fulfilled. Now, if you are understanding this problem with this numerical, suppose 5 item having 30 weight, 30 value, 10 weight of item having 20 value, 20 weight of item 100. So, firstly, what these are items and these are values. What we have to do? We have to find out the per unit item and sorting this. So, after sorting, item 1 is having maximum benefit, item 3 uske baad, then item 5 is next, then item 4, then item 2. Now, what is the capacity of knapsack? Knapsack capacity equals to 60. This is the 60. So, firstly, you have to pick 5. So, weight equals to now 5 and value equals to 30. Now, rest weight is 60 minus 5 equals to 55. Now, you have to pick 20. The weight is, the profit is 100. And 20 item, if you are taking, next, the left value of knapsack is 35. Now 40 items are there. You cannot accommodate all 40. Then you have to find out the profit of 35 items. You have to pick 35 items and the total profit equals to 30 plus 100 plus 35 into 4. That is equals to 130 plus 140. That equals to 270. So, the total profit is gaining by applying this algorithm is 270 and the total knapsack capacity is 60. So, whatever item is participated into that, I1 completely, I2 0, I3 completely, then I4 0 and I5 into 0.35, 35 by 40 items. So these are, and so this is the solution set for the problem. So this is the fractional knapsack problem. We can get this 270 is the maximum profit and this will achieve by using these values, means the maximum profit value 5 is total used, 20 is then again used and 35 is again used. And knapsack is also fulfilled and we are getting the final solution. So this is the problems related with this greedy algorithm. Minimum spanning tree, single source shortest problem. These are the different kinds of problem for which we are applying this greedy algorithm and it is very successful. So today I am only cover this particular till this particular topic. Next time I will be going on some another topic with this. Thank you very much.